For decades, Pluto was considered little more than a frozen relic drifting in the darkness beyond Neptune. After its reclassification as a dwarf planet in 2006, many assumed its scientific importance had faded forever. To most people, Pluto became an afterthought, a distant object at the edge of the solar system. But science has a habit of surprising us. The deeper astronomers look, the stranger Pluto becomes. What once appeared to be a small, inactive world is now emerging as one of the most complex objects ever discovered in the outer solar system. The turning point came in 2015 when NASA's New Horizons spacecraft raced past Pluto and delivered humanity's first close-up look at the distant world. The images stunned scientists. Instead of a crater-covered frozen wasteland, Pluto displayed enormous plains, towering mountains made of water ice, flowing glaciers, and landscapes that appeared surprisingly young. The most famous feature was a gigantic heart-shaped region stretching across the surface. Known as Sputnik Planitia, this vast basin immediately became one of the most intriguing locations in the solar system. At first glance, it looked like a frozen desert. But closer analysis revealed something extraordinary. The nitrogen ice covering the region appears to move slowly over time, behaving almost like a glacier on Earth. This suggested that Pluto was not geologically dead. Something inside the dwarf planet was still active. The question was simple. Where was the energy coming from? Pluto is nearly 6 billion kilometers from the Sun. Temperatures can drop below -220 degrees Celsius. Under such conditions, most scientists expected any internal activity to have ended billions of years ago. Yet the evidence suggested otherwise. One explanation involves a hidden ocean buried beneath Pluto's icy crust. Researchers believe a layer of liquid water may exist deep underground, insulated by thick ice above it. Heat produced by radioactive elements inside Pluto's rocky interior could be preventing that ocean from freezing completely. If true, Pluto may contain more liquid water than many worlds much closer to the Sun. The implications are enormous. On Earth, wherever liquid water exists, life tends to follow. From deep ocean trenches to underground caves, microorganisms have adapted to environments once thought impossible for survival. This raises a fascinating possibility. Could Pluto's hidden ocean support life as well? Scientists don't know the answer. But the question alone has transformed Pluto from a forgotten dwarf planet into one of the most exciting targets for future exploration. The evidence extends beyond underground water. Gigantic fractures stretch across parts of Pluto's surface. Some regions appear surprisingly young compared to the age of the solar system. These observations suggest Pluto may still be evolving today. And if that's true, then this distant world is far more dynamic than anyone imagined. But Pluto has another secret. One that may be helping keep this frozen world alive. Its unusual relationship with its largest moon, Charon. Together, they form one of the strangest planetary systems ever discovered. And that partnership may hold the key to Pluto's hidden activity. Unlike most planet-moon systems, Pluto and Charon behave almost like a double world. Charon is so massive relative to Pluto that neither object truly orbits the other in the traditional sense. Instead, both worlds circle a common center of gravity located in the empty space between them. It is a cosmic dance unlike anything seen among the major planets of our solar system. For billions of years, this gravitational partnership has shaped both worlds in ways scientists are only beginning to understand. Every orbit creates subtle stresses within Pluto's interior. These tidal forces may flex layers beneath the frozen crust, generating heat that helps prevent a hidden ocean from freezing solid. While Pluto appears frozen and motionless from afar, deep below its icy surface another story may be unfolding entirely. Imagine an ocean trapped beneath kilometers of ice. An ocean that has existed for billions of years. An ocean hidden from sunlight, protected from the harsh environment of space, and isolated from the rest of the solar system. If such an ocean exists, it would instantly become one of the most intriguing environments ever discovered. On Earth, life has shown an astonishing ability to survive in places once thought impossible. Microorganisms thrive around deep-sea hydrothermal vents where no sunlight reaches. Entire ecosystems flourish beneath Antarctic ice sheets. Life adapts, survives, and evolves in ways that continually surprise scientists. This is why Pluto has become such a fascinating target. The possibility of liquid water means the possibility of chemistry. And where chemistry becomes sufficiently complex, biology may eventually follow. But Pluto's mysteries extend far beyond the question of water. One of the most surprising discoveries made during the New Horizons mission was Pluto's atmosphere. Despite its tiny size and extreme distance from the Sun, Pluto maintains a surprisingly active atmospheric system. Thin layers of nitrogen, methane, and carbon monoxide drift above the surface, creating delicate hazes that stretch hundreds of kilometers into space. These hazes are unlike anything expected on such a distant world. As sunlight interacts with atmospheric molecules, it triggers chemical reactions that produce increasingly complex compounds. Over time, these reactions generate reddish organic materials known as tholins. Tholins are not living organisms. Yet they are incredibly important because they represent the kind of complex organic chemistry that may have played a role in the early history of life on Earth. In a sense, Pluto may be acting as a natural laboratory, preserving chemical processes that occurred throughout the young solar system billions of years ago. Every new observation seems to reveal another layer of complexity. The giant nitrogen glaciers of Sputnik Planitia appear to move slowly across the landscape. Vast ice mountains rise several kilometers above surrounding plains. Deep fractures cut through frozen terrain. Some regions appear surprisingly young, suggesting ongoing geological activity. These discoveries have forced scientists to rethink long-held assumptions. For decades, objects in the distant Kuiper belt were considered frozen leftovers from planetary formation. Ancient relics preserving the conditions of the early solar system. But Pluto refuses to fit that simple picture. Instead of a dead world, it appears active. Instead of a static world, it appears dynamic. Instead of a simple world, it appears incredibly complex. And if Pluto can remain active after billions of years, what about the countless other icy worlds scattered beyond Neptune? Could hidden oceans be common throughout the outer solar system? Could entire ecosystems exist beneath frozen shells on worlds we have never visited? Could life emerge wherever the right ingredients persist long enough? These questions are no longer science fiction. They are now legitimate scientific investigations. Future missions may provide answers. Scientists have proposed ambitious concepts ranging from long-term orbiters to advanced landers capable of studying Pluto for years. Some proposals even imagine cryobots that could one day melt through thick layers of ice and explore the ocean below. Such missions would be among the most challenging ever attempted. Pluto lies billions of kilometers away. Communication delays are measured in hours. Travel times are measured in decades. Yet history has repeatedly shown that humanity is willing to pursue the most difficult destinations when the scientific rewards are great enough. And Pluto may offer some of the greatest rewards of all. Because Pluto is no longer simply a distant dwarf planet. It has become a symbol of how much remains undiscovered. Every generation believes it understands the universe a little better than the last. Yet again and again, nature reveals surprises hidden in places we least expect.